Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Differentiate the following y equals tan 3x, right? So this is a very simple problem. Again, an application of the chain rule. The way we go about solving these problems, and let me put out the chain rule here, folks. So this is my chain rule. Let y equal to f of u be a function of u, and in turn u equals g of x be a function of x, so that y equals f of g of x. Then my dy dx of y equals dy dx of f of g of x, which is equal to f dashed of g of x into g dashed of x, right? So we'll go ahead and solve this problem by substitution. And what I mean by substitution is I substitute the expression 3x by a u, right? So let my u be equals 3x, right? And when u equals 3x, what is my du by dx? My du by dx is nothing but 3, right? Let's park that aside and then let's move to the next line. And then I'm going to do a substitution of y and represent y in terms of u, right? So let's do that. My 3x has been substituted as u, right? So I do substitute the 3x with u in my expression. And what do I get as my y? So now my y equals tan u, right? And what is my dy by du? My dy by du, we know that for tan, we've derived this earlier from first principles, and if you've not seen my earlier videos, I put a link to the description. I put a link to the video in the description. Please do take a look at it to understand what is d by dx of tan x using first principles, right? So my d by du of tan u is nothing but secant squared u, right? So we have dy by du, we have du by dx, but we've been asked to find dy by dx, right? My dy by dx is nothing but dy by du into du by dx, right? Right, so what is my dy by du? I have the answer here, secant square u. Then what is my du by dx? I have the answer here, which is my 3, right? So let me highlight this, folks. Let me highlight both. So this is my du by dx, which is my yellow portion. And my dy by du, let me call it by the color green, and I have that as secant square u, and I'm gonna write it like this, right? So here we have an expression in terms of u, right? So we've been asked to find dy by dx, so our final answer has to be in terms of x, right? So I go back, I substitute my u into in terms of x, right? So what is that? 3 secant square times 3x, right? So that's our final answer, right? So again, going back to the chain rule or the composite rule, when we have a function f of g of x, and what is a g of x in this particular problem? It is 3x, right? So, and I have a function tan, right? So my f of g of x is tan 3x, where my g of x is 3x, right? So I differentiate tan with respect to 3x, which means my first part, I don't touch the 3x, so I differentiate it. I write 3x as it is, which is what you arrive at secant square 3x, right? So that is my portion 1. And then I go ahead and differentiate my g of x, which is nothing but my g dashed of x, right? Let me call it by the color green. And then my yellow part, which we just saw, which is, my secant, I'm sorry, let me call out by the color yellow, and let me call f dashed of g of x by the color green, so which is our secant square 3x. And I go ahead and differentiate my g of x to arrive at g dashed of x. And what is my g of x? My g of x is 3x, and differentiate that, I get 3, right? So which is again, I'm going to call it by yellow, right? So that's how we arrive at our answer. So d by dx of tan 3x equals 3 times secant square 3x. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.